All right, so in section 2-6, we're going to focus on proving angles congruent. We're not going to worry about the review. Let's look at theorem, the definition for a theorem. A theorem is a conjecture or a statement that you prove true. The difference between a theorem and a postulate: a theorem has a formal proof written behind it, whereas a postulate does not, although we know that we could prove it true with a theorem if we wanted to. Typically, postulates are facts. A lot of them are facts. Some of them are just things that don't have formal proofs behind it. But a theorem just means it has that formal proof behind it. So if you're trying to do the proof of the angle addition postulate, you can't use the angle addition postulate in the proof of the angle addition postulate. Just saying. If you're proving a particular theorem, you can't use that theorem within that proof. So true or false, a postulate is a theorem. What do you think? A theorem is a conjecture statement that you prove true. Did we prove a postulate true? Prove it with a proof. No, that's false. A theorem may contain definitions. True. An axiom is a theorem. Well, you have no idea what an axiom is, do you? Well, we're going to come back to that. So you're going to wait for that one. In fact, why don't you write yourself a note and look up that definition tonight. Or your homework. So you've got several postulates from chapter 1 that are going to come into play here. So all of these postulates should have been on your flashcards, and you should have memorized them and learned them. Through any two what, there's exactly one line. Points. I'm going to write it here because I like it where it belongs. If two distinct blank intersect, then they intersect in exactly one point. Lines. If two distinct blank intersect, then they intersect in exactly one line. Planes. Through any three non-collinear blank, there's exactly one plane. Points. These are all things that will be used in proofs. Let's flip it. So here's one that we already talked about, but now there's a formal theorem behind it. Vertical angles theorem. I mean, you may not call it theorem 2-1, and you're not allowed to use vertical angles theorem as the reason in your proof. You have to state what it says. And so what it says is that vertical angles are congruent. So anytime that I'm showing that two angles are congruent in my proof, and the reason why I know that is because your reason will be vertical angles are congruent. So learn it, put it on the flashcard. So problem number 1, what is the value of x? So circle the word that best describes the labeled angled pair in the diagram. So look at the angled pair. Are they corresponding angles? Are they perpendicular angles? Are they vertical angles? In this diagram here. What kind of angles are those? The one that's labeled with the 3x and the one that's labeled with the 2x plus 40. They are vertical, right? And the minute that your brain identifies them as vertical, what is the conclusion that you make about them? That they're congruent. So circle the word that best describes the relationship between the labeled angles. They are congruent. So use the labels in the diagram to write an equation. 3x is equal to 2x plus 40. And you solve that equation. Long solution, isn't it? So what did you get for x? 40. If you're not sure if that's correct, what can you do? Check it. So I'm going to take 3 times 40. That should be equal to 2 times 40 plus 40. 3 times 40 is 120. 2 times 40 is 80, plus 40. Doesn't 120 equal 120? And do these look like they're obtuse angles? Yep. So knowing that, I can now tell what this angle is. What's this angle? Because if 3x is 120, what's this angle? 60. Why? What do these to each other? They're what? It's a straight angle, which means that they are supplementary. So there we go. All right, so we're going to do a proof using vertical angles theorem. We're going to stop after this proof. So use the vertical angles theorem to prove the following. So they have given you all the statements, and you have to fill in the reasons. This is a typical question on your test. I will not make you do a full proof by yourself yet. So on this test, you will have all the statements, but you must come up with the reasons. If I don't give you all the statements, it's an extra credit question. Fair enough? Okay. I have been known to put the exact proof from your homework or your notes on a test. Why do you think I would do that? I want to see who's actually studying. If you actually truly study, then I'll catch you. Or if you actually truly don't study, then I'll catch you up and be able to tell immediately you didn't study for the test because you didn't recognize that proof. So we have not had that many proofs. So make sure that you know that. All right, so we are given that angle 1 is congruent to angle 2. So I'm going to mark up my picture. And although the picture looks like those lines are perpendicular, can I assume that? No, there is no little right angle marker in there at all. Our job is to prove that all 4 angles are congruent. Okay, so we start off with, well, let's just pre-plan this. If angle 1 is equal to angle 2, then what can you conclude? Well, don't look over here. What can you conclude just from the picture? If these 2 are congruent, what else do you conclude? I can't necessarily conclude that 2 is congruent to 3, but I could conclude that 2 and 3 are what? They're adjacent. What else can I conclude? They're a straight angle, right? So then, so I guess instead of then it would be and. And angle 2 and angle 3 are a linear pair or a straight angle or whatever. So then I could conclude that from there that those are supplementary, right? And that they had a 180. So once I conclude that, then couldn't I conclude that 1 and 3 are congruent? I could just actually jump to that already, couldn't I? Just from using vertical angles. So instead of even doing that, I could do angle 1 is congruent to angle 3. Why? Because they're vertical. What else is vertical? What else is vertical? 2 and 4. So angle 2 is equal to angle 4. Why? Because they're vertical angles. And if this was a given, don't I have 1 and 2 here? If 1 and 2 are equal, then what can you conclude? That 3 and 4 are equal. Right? And then finally you can just string them all together. So look what they put. How do we know this? It's given. Always. If I leave that top one blank and you know nothing else about a proof, I know that you have at least been somewhat awake if your first reason is given. And if I left this last statement blank, I know nothing else but that the proof is always the last statement. So you should never miss the first reason or the last statement, ever. Ever, ever, ever. Because if you miss those, it means you've been asleep. And you haven't been, because those don't take any thought whatsoever. All right, then from here to here, did I conclude anything from here to here? What's 1 and 3 to each other? And what did we say in our pre-proof planning? Yeah, so there's nothing from here to here that I can conclude, but just the fact that looking at the picture, 1 and 3 are congruent. Why? Vertical angles are congruent. And you can use those abbreviations. So you can use angle markers as abbreviations, congruency markers as abbreviations. What's 2 and 4? Also, those are vertical. So again, vertical angles are congruent. So I personally, I don't know as if I would have gone directly from here to the fourth step, but they did. I probably would have said that angle 3 is congruent to angle 4 first. By what reason? How can I go from looking at those two to saying that angle 3 is congruent to angle 4, actually looking at these three? I went from here. 1 is equal to 2. 1 is equal to 3. 2 is equal to 4. How can I go to 3 is equal to 4? If 1 is 3, can I replace 1 with 3? And if 2 is 4, can I replace 2 with 4 and go directly to 3 equals 4? That's why. And what property would that be? Substitution. So what property are they using from here to here? Because angle 1 is congruent to angle 2, right? So we're stringing that together. And then they're stringing the fact that 3 is also equal to 1 and 4 is also equal to 2 through that same one substitution. Prop. How do you call it? So there's little mini proofs right now. Yes?
Would you also say that like two perpendicular lines can be 4?
No, because we don't know that the lines are perpendicular.
Oh.
We could now arrive at that conclusion because the 4 angles are congruent. We could then develop that conclusion, but we can't make that conclusion from the beginning because we were not told that they were perpendicular from the beginning. If we were told that, then you can conclude immediately that all 4 angles, but you haven't been given that postulate or theorem yet. Does that make sense? All right, so then we're going to do we're going to do 3 and 4 tomorrow, but just let it be known. Paragraph proof. I would never test you on paragraph proof because that would require me to have to grade it. Just let's be honest. But a paragraph proof is no different than what we just did. Only you take the statements and reasons in if-then form and just write them as sentences. If this and that, if this and that, and we develop that whole paragraph. So proofs can come in many different forms. The 2-column format is the most popular, but there's also flowcharts and paragraphs.